Quadratic inequalities, algebra 2 trig regions. What is the solution set for x squared minus 4x minus 5 less than 0? So, in the past, we've done absolute value inequalities. And you're going to see some similarities between those. But for the absolute value, what we did for less than was we kept it less than the whole time and put, the negation of the other side and so on, and greater than, add an or statement. And you're going to see, again, some similarities that when you have less than, you are going to end up with a statement where x is between values. But if it was greater than, then it would be an or statement. So that's still there. But as far as the process for solving these, what we do is we temporarily cut out the inequality sign and think of it first as an equation. And for quadratic equations, we always set them equal to 0. So make sure it's set equal to 0. So if this isn't 0 over here, you have to move it over and make sure it's set equal to 0 first. Once it's set equal to 0, we factor. And this is some basic factoring right here. Factors to x minus 5 and x plus 1 equals 0. And then you set each factor and solve those. So x minus 5 equals 0. I would add 5 to obtain x equals 5. For x plus 1 equals 0, I'd minus 1 away to get x equals negative 1. Now, when it came to absolute value, what we had to do is we had to check these numbers to see if they worked, because often they didn't. That's not the case with quadratics. You do not need to check them, but these are not necessarily answers. Remember, for inequalities, they're what we call the critical numbers. And so what's going to happen here is if you were to put this on a number line, negative 1 would go on the left and positive 5 would go on the right. And then we have two possible scenarios here. You could have the in-between statement with a bar connecting, or you could have an or statement, which would result in the arrows away. And what we're going to do is basically, if it's less than, it's going to be an in-between statement. So because it's a less than, we're going to do in between. And notice that these circles are open because we're not also equal to. If it were less than or equal to, I'd shade them in, but it's not, so I'm not. And so that's it. That's my answer there, is x is between negative 1 and 5. This x slash just means x such that x is between negative 1 and 5. And what this is saying is all the numbers between negative 5 are in the solution. Now again, because we're not doing equal to, because these circles are not shaded in, that means that negative 1 and 5 are not in the solution. The solution would be 0, 1, 2, 3, and 4, not including negative 1 and 5. And if you plug any of these numbers in here, they should work. Let's pick an easy one. Let's pick 0. 0 squared minus 4 times 0 minus 5 is less than 0. So that would be 0 minus 5 less than 0. These are gone, and you end up with negative 5 is less than 0, and that's true. And so that's it. And that's honestly what you could do. If you never remember, like, say, like, I can't remember if it's between or arrows away, you test it. Test a number in the middle, like 0. Or you could test a number out here, like 7. The numbers in here will work. Numbers out here won't, meaning they'll come up false. Like if we plug in a 7, we'll end up with a false statement, like 6 is less than 0, which is not true. So if you ever don't know, you pick a test point. And you could also test something out here, like negative 5, but typically when we see that less than, we know it's going to be between. Let's just try one more, but this then with the greater than sign. So I see a greater than sign here, which tells me that the odds are it's going to end up being an or statement. Now the first thing I said to do is to make it an equal sign. So x squared minus 3x equals 10. And then for all factoring, it needs to be set equal to 0. So x squared minus 3x minus 10 equals 0. And that's really an important thing to forget. Just don't forget to set equal to 0. Now we may factor. And the factors are x minus 5 and x plus 2 equals 0. And that would then, in turn, give me solutions of positive 5 and negative 2 when I solve each of these equal to 0. So these are my test numbers, my critical numbers, I call them. And so negative 2 would be on the left and 5 would be on the right. These would be open circles because, again, we don't have the equal to. Equal to would close them in. So right there, it tells me that negative 2 and 5 are not in the solution. What's either in the solution is going to be either between or away. Greater than is away. And some people like to remember that by the word greater kind of sounds like it has the word or, greater or. And then for less than and is kind of like and, meaning it's in between. But I think the greater than or actually does kind of help you remember that. But again, as I mentioned in the previous problem, we could do a test. So say we test 0, something in the middle. You plug in a 0 here, you're going to get 0 squared minus 3 times 0 is greater than 10. That's 0 and 0, so you end up with 0 greater than 10. This is a false statement, so it makes sense that 0 is not in there. But if we test stuff on the ends, like let's test 6, for example. That would be 6 squared minus 3 times 6 greater than 10. That's going to be 36 minus 18 greater than 10. You end up with 18 is greater than 10. That is true. And the same thing if you test something like negative 5 over here. And so you can always test it out. And so the inequality solution for this, remember when it's an or statement, it's less than the lower, so less than negative 2, or greater than the larger, greater than 5. And so that's the answer here. Sometimes people know it's a greater than, so they know it's an or statement, but they forget which one is less than, which one's greater than. But if you picture the number line, the lower of the two numbers is on the left, and so it's less than the number on the left, and the greater of the two numbers is on the right, so it's greater than the larger right there. And that's really the two ways this could go. It's going to be less than between, greater than or. And the key is that you think of it first as an equal sign, set it equal to 0, factor solve, and go through the process that way. All right.